Hello and welcome back. This is the third video on some of the earlier concepts to study for the ACT math section. If you haven't seen the other videos, go check those out because these are going to build on the area concepts that I did discuss. But if you're pretty comfortable with the area already, or if you'd rather just jump right into it, I do give you the area formula that you need to know for any of these problems. So you will be okay just to start here. But before I get right into this, if you do find the video helpful, as always, leave a like, subscribe if you'd like to help me out, or just see when I post more videos. And if you have any questions or something you'd like to see more examples of, or any other thing you'd like to let me know, leave a comment, and I'll be sure if I can see if I can help you out. So this video is going to focus on advanced area problems. So what are primarily two problems where they're going to do funky things with area? The first is going to be area between two shapes. That's a really common problem where they give you one shape inside of another shape. Sometimes it's a rectangle and a rectangle, sometimes it's a circle and a square. And they're going to ask you what's the area between them. It's a very simple problem, but a lot of people, most of my students, have just never seen this before and just don't know what to do or even what they're asking for. So that's why I'm going to cover it here. But I do see this on almost every single test that I have covered with my students. Not every time, but most of the time. Sometimes there'll even be several questions in one test, so it's an important type of problem to know. So how do I solve it? All you have to do is subtract the area of the smaller shape from the area of the larger shape. Now, if that doesn't make sense in a word structure like that, I'm going to break it down step by step. First, get the area of the larger shape. I'm just going to call this A large from now on. Second, get the area of the smaller shape. That's A small, or at least that's what I'm going to call it from this point forward. Then you just subtract. That area between them is going to be A large minus A small, and that's it. As I said, pretty easy. You just need to know what to do. But obviously that still might be confusing because you don't know what this looks like. I'm going to go into a few examples here, but before I do, read this. Always double check the units that they give you and what units they want for the answer. If they want different units, convert the units first, every time. It's extremely important because it's a super common trick that they like to put into the test. There is a way to convert at the end, which is what a lot of people try to do, but there's a very common mistake that almost everybody makes if they try to do that. So if you convert first, you don't have to worry about it. But I'll go into what that is earlier and give you an example. So let's get into an easy way of doing this first without having to worry about those units. So, example. Here's a shape. What's the area between these two rectangles in square feet? So, the area between is this gray area. So we have the large rectangle, that's 10 by 5, and a small rectangle, 3 by 2. So if they say what's the area between the rectangles, they're talking about this gray spot. Now, the ACT is probably not going to color it for you or say the gray area. I just put it here so you can know what they're even talking about. Essentially, all this is what's the area of the big rectangle if it had a big hole in it, the size of this small rectangle. That's why we just subtract. So as a reminder, area of a rectangle is just length times width. So let's solve it. Get the area of the large one first. 10 feet times 5 feet, that's 50 feet. The area of the small rectangle then is 3 times 2, so 6 feet squared. And subtract. 50 minus 6, their answer is 44 feet squared. Not too bad. Like I said, it's pretty easy. You just need to actually know what to do in the first place. So, in this case, I just went right into it. I didn't worry about units or anything. So, why could I do that? Because the answer they want, it's in feet. And everything they give me is feet. So I was good to go. So what happens if they give me the same problem, but they ask for the answer in square inches? But everything I have is in feet. I've got it in bold here. If you're lucky, the ACT question will also put it in bold, or they might put it in italics, but a lot of times they don't do anything to draw your attention to it. So if you see units on any problem, not just these, just double check. So let's solve this. As I said, always convert to your final units first. So I'm actually going to show you the right way to do it and then the wrong way to do it. But keep in mind, there's technically another wrong way, and that's to just not even notice that they ask for it in square inches and do what we just did earlier, where we solved everything in feet and gave the answer in feet squared. So let's solve this the right way. So to begin, I'm going to convert everything that's in feet to inches, because that's how we want our answer, is in square inches. So if you don't remember, to go from feet to inches, we multiply by 12, because there are 12 inches in 1 foot. So I'm going to go multiply all these by 12. I'll hit the button, and there you go. Magically, there's your units in inches. Again, as I said before, to go from here to here, I just multiplied by 12. So now that I have all of my units in inches, and we want square inches, I'm good to solve this just like I did before. So subtract the smaller area from the larger area. A large now is 120 times 60, because I'm using the inches here, to get 7,200 square inches. Those are some big numbers, but remember, you have a calculator. Now we'll get the area of the small rectangle with the inches. 36 times 24, you get 864 square inches. And then subtract, and you get 6,336 square inches. It's a big number, but not too bad. Now, remember this number, because I'm going to go solve it the wrong way now, and you're going to see I'm not going to get anything close to this. So let's go do this. Now again, I really want to point out what I'm about to show you is the wrong way to do this. So do not do what I'm about to show you. And that would be solving it in feet first and then converting. Technically you can do it, and I'll show you how on the next slide as to why it's not a good idea, because there's a big mistake that most people are going to make. So let's just do this in feet first by subtracting the small area from the large area. So the large area, 10 times 5 is 50 feet squared. The smaller area, 3 times 2 is 6 feet squared. So subtract, and that area between is 44 feet squared, just like we got earlier. That's technically correct. The problem is in this last step, where we convert from feet squared to square inches. What most people are going to do is, to go from feet to inches, you multiply by 12, right? So therefore, 44 square feet times 12 gives me 528 square inches. That's not correct, and I'll show you why on the next slide, but you can see this is way smaller than the 6,336 that is the correct answer. So that is why we will always convert first instead of at the end. But why didn't this work? Well, the reason is because that conversion was incorrect. That multiplying by 12, because there's 12 inches in 1 foot, that's going from feet to inches. But what we were actually trying to convert there was feet squared to inches squared. So to do that, you actually have to square your conversion. Or if we're talking about volume, it would be things like feet cubed and inches cubed. So what we just did is we took the 44 square feet multiplied by 12 inches per foot and said that's this. But the problem is, notice this is squared, these are not. So you can't do that. If you did want to go from feet squared to inches squared, you can, but you have to square this 12. So that way, your units here are also squared. So everything is squared in your units, and you're good to go. If we were doing this with volume, and these were cubed and this was cubed, you'd have to have 12 cubed to do your conversion. So, if you prefer to do it this way, you can, but you better remember to square that conversion factor. Probably going to forget that, because most people, even those that know how to do it, some of my smartest students, whenever they try to do it this way and they're going quickly on a time crunch, they're going to forget, and they're going to do this and get the wrong answer. So if we just convert first every single time, you never have to worry about that mistake. So just a reminder, this, the wrong way, that answer is going to be an option every time, because that's what they're trying to see if you do the wrong way. So that's really it for the area between two shapes. But since I was just talking about converting units, I wanted to throw this slide in here real quick. There's not a lot of unit conversions on the ACT, but here are 4 that you should probably just know. So pause for a second, read these 4. If you don't know them, write them down, memorize them. So now I'm going to move on. Let's look at one more trick problem with the area between two shapes. Then we'll go to the last not area between two shapes problem. In this case, it's a word problem, and they're going to give you something along these lines. A cake is 15 inches long and 6 inches wide. It sits on a plate that extends 3 inches beyond the cake on all sides. What's the area of the plate that isn't covered by the cake? Now, they didn't say area between this time, but that's what they want, is they want the area between the edges of the plate and the edges of the cake. So when you see something like this, first thing you should do is draw a picture, because they're probably not going to give it to you. Sometimes they might, but normally they don't. So let's just draw it. A quick sketch. That way you can see what's happening. So now it's a little easier to see. Here's my cake. Here's my plate. I want this gray area, which is the exposed plate that's not underneath the cake. So you solve this just like everything we just said. Get the area of the bigger one, the plate, the area of the smaller one, the cake, and subtract. But if you look at this, I don't have the dimensions of the bigger one. And that's where the mistake comes in. That's where this trick problem is most people look at this and think, well, it extends 3 inches beyond the cake, so I just have to add 3. So this must be 9, and this is 18, right? Well, there's a problem with that. As you can see, this is 3 inches beyond this 15 on this side, but it's also 3 inches beyond on this side. So I actually need to add 3 2 times, so adding 6 to that 15. And same thing with the 6 here, which goes from here to here. To get from here to here, I have to take that 6 and add 3 on this side and add 3 on this side. So I'm really adding 6 again. So add 6, not 3. So you end up doubling this to your length and width to get 21 and 12 instead of 18 and 9. That's the trick. If you had made this 18 and 9, the answer you get will be an option. It'll be the wrong one. So, once you have this, you solve this the exact same way as everything we were just doing. Get the smaller area, the larger area, and subtract. So in this case, the larger is 21 times 12 inches, 252. The smaller area is 15 times 6 inches, which is 90. And subtract, and you get 162 square inches. Not too bad, but just keep in mind if it's ever extending beyond, it's probably going to extend on both sides, not just one. Alright, that's it for area between two shapes. Let's get to the last type of problem, and that's the how many fit problem. So you're going to want the max number of something that'll fit or the minimum number. So here's an example. A patio is planned to have an area of 750 square inches. If bricks are 2 inches by 3 inches by 5 inches, what's the minimum number of bricks needed to make the patio? So to do this, you just have to divide the area of the big thing, in this case the patio, by the area of the bricks. So where earlier we were subtracting, now we're dividing. But here's the problem where people get stuck. They gave us 3 numbers, and to get area, I only need 2. So which 2 do I use? Well, we have to realize that you can lay down those bricks 3 different ways. You can lay it so it's mostly flat, you can tip it to its side, or you can tip it all the way on the other side where it's sticking straight up. It would be awkward, but you could do that if you wanted to. So we need to think about the goal here. If we want to use the minimum number of bricks, then we want each brick to take up as much space as possible. That way I don't need as many of them. So if I want them to take up as much space as possible, I'll lay it so that they use the 2 largest sides to get the area. On the other side, if we wanted to get the maximum number of bricks in there for some reason, you'd lay it so that each brick takes up as little space as possible, so I can pack more of them in there. So to do that, you would lay it so that way the area is using the 2 smallest sides. So I'll go solve it both ways, beginning with minimum. So what's the minimum number of bricks needed to make the patio? Again, if we want minimum, then we need each brick to take up as much space as possible, so I don't need as many bricks. So to do that, we'll need to use the two largest sides. So that's the 3 and the 5. So that means the area of the brick will be 3 times 5, 15 square inches. And that just leaves dividing the 750 by the 15. So the minimum number of bricks that I need, 750 divided by 15, 50. And there you go. Now how about maximum? So same problem, same numbers, but what's the maximum number of bricks I need to make the patio? In this case, I want the bricks to take up as little space as possible so I can pack them all in there. So I'm going to lay them differently so that way I'm only going to use the smallest two sides to get the area. So now the area of the brick is going to be 2 times 3. Those are the two smaller sides, 6 square inches. And now I'll divide just like I did before. 750 divided by 6. Excuse the typo there, that should have switched that to say maximum number of bricks instead of minimum. But the max number of bricks is now 125. So hopefully that makes sense as to which sides to use. Use the smallest ones if we're trying to pack them all in there and get as many as we can. Use the biggest ones if we're trying to take up as much space as possible, and use the fewest of them that we can. And that'll pretty much cover everything for this video. Do keep in mind the same thing works if they ever have a volume type one. Where it's like how many maybe marbles fit inside of a jar. You'll just divide the volume of the jar by the volume of the marble. In that case, you don't have to worry about which sides to use, you just have to know volume equations. Not too common, but I'll cover volume in another video. So hopefully you found this helpful, and I'll see you in the next one. Good luck.